All right, we're back, and it's COMP1004. That's Rapid Application Development, and we are in week 12 of part 2 in the winter 2017 semester. I don't know why I thought I'm thinking Unity 5 here at Georgian, right? Where we are talking about Unity 3D and how do we use Unity 3D from a rapid application development perspective, right? Unity 3D is great because it allows us to make games really quickly, but it also allows us to use make interfaces for any platform. All right, so we talked about our little slot machine interface. That's great. But let's talk about the Unity interface from scratch. If you've never seen Unity before, this is a good chance to kind of take a look at this and learn about Unity. Really direct you, and like I've talked to you before, is the actual Unity site itself. If you're really interested in learning about Unity 3D, if you go there and then you go to Learn, so that's actually Unity 3D/Learn, there are a ton of tutorials here, like we've mentioned before in the past, right? Everything you want to learn from a 2D and 3D perspective, if you want to make some simple games and interfaces, you can learn from beginner to intermediate and into advanced. Everything from making a simple rollerball kind of game to a space shooter tutorial to fully working tanks tutorial. There's again 2D and even 3D stuff. Like procedural cave generation, definitely more difficult to do than something like this. So all kinds of opportunities here, and it's right on the Unity site. Great learnings. The other opportunity for you to learn is through an outfit like lynda.com, which I'm going to kind of specify as well. Lynda.com has some really good tutorials on Unity as well as everything else, right? So if you look at the library for lynda.com, if I look at Unity, and I press enter, you can see that there is a bunch of stuff here for Unity, Unity 5 network game simulation, right? Lots of little videos. But there's also a whole tutorial on how to build things for Unity. So if you want to look at library, and if I want to, if I just wanted to see things with Unity, there it is, just Unity software. Then that's Unity 5 network gaming, building a character, learning C# for Unity game development, Unity 5 2D, building an adventure game. There's tons and tons of little tutorials here. And even things like Unity 5 2D essential training, right, which is where you can start off. If you want to learn Unity, it's one of the best resources that I've seen. The other one that I like is there's ones on online for games. You can go to 3D Motive. 3D Motive is actually another one that has things like Unity. It teaches you about other systems, ZBrush, if you like, or 3D Studio Max, Maya. Anything you want to learn about game development, a lot of stuff is talked about here. And the last one from a professional tutorial perspective is Pluralsight. Pluralsight also talks Unity development. If I looked at Unity 3D, right? You're going to have a bunch of courses on Unity here, right? Lots of little stuff that you can learn. Now, what if you're like me and you're very busy and it's week 12 and you got week 13 and week 14? When are you going to learn how to do Unity? So I'm going to show you some stuff today. But like I said to you, next week when we do our lab, I'm going to do this check and X. Did you start your project? And if nobody used Unity by next week, then we won't do Unity next week. Because my assumption is going to be like nobody's going to do Unity. So why am I going to waste your time with Unity, right? I'll do something else with C#. I'll have an alternate plan for that day, right? But if people are using Unity, then I'll show you Unity. It's a really good little system to use. It's probably the easiest to learn compared to something like Unreal. The other platform you can use to make games quickly is the Unreal Engine. I can't really, and there's other ones too, but these are the two big ones. Unreal, right? Does everything from 2D and 3D, right? Again, mostly used for games, but you can also use it for other things. There's a different lighting system. The way they do lighting and the way they create things in Unreal is a lot different. And if you're taking the third-year program here at Georgian, we do have a course in game and simulation where we do use Unreal to create our games. So if you're going to go to third year, the game and simulation option, we teach you how to do Unreal with blueprints, not necessarily with C++. Okay, so that's something if you want to think about later on. But for us, we want to use Unity. And again, like I talked about before, I want to make this kind of simple. So let's start off on the top left. So I'm going to just put my Unity on the right. And on the top left, there's these little keys. There's a little hand key on a little, kind of a, looks like a cross with little arrows, right? These little icons here that show kind of a little arcs. And this one here, all these different controls here do the basic movements, moving things around in your scene, right? Here in Unity. Now, instead of using this application, which is the slot machine, I'm going to make a new application, and I want to talk about Unity's interface a little bit more. Okay, so let's do that. So I'm going to kind of go to File, and I'm going to close down the Unity application by quitting. And I'm going to make a new one. So I'm going to go to Unity. And I'm going to choose a 2D application because we're working with 2D, right? Let's make a new one. And I'm going to share this one with you on GitHub, right? So I'm going to show you the difficulties when working with this, right? Now, we kind of did this earlier, but I want to talk about it again. So COMP1004, and it's the winter 2017 semester. We're into lesson 12 already. We're going to click on 2D instead of 3D. And we're going to turn analytics off. And I'm going to create a new project. So what I want to do here, notice how it kept my changes. All my settings that I had recently, all these things that I made, it kept. I'm going to go back to my default layout because I want to show you what it looks like by default. This is what it looks like I said. So on the top left corner, you have these little controls. By the way, all those controls are controlled by Q, W, E, R, and T. If you actually use those keys, those are the hotkeys for those controls up above. Okay? I'm going to change my layout back to what it was before. So I'm going to go from default to 2x3 because I find this is a little easier to work with. And I'm going to modify my 2x3 layout by taking my project panel and pulling it down into my hierarchy. Right? There we go. So you can resize these windows like I'm showing you, but just by going to the edge of the window, waiting for your mouse to change, your cursor to change to something like this. What it allows you to do is kind of pull across so you can compress these windows here as much as needed, right? Why am I compressing? I want the maximum amount of space here in my scene or my game. For now, all I want to do is work with my scene. So I'm going to pull my game into here. So I see my scene really big. All right. By default, Unity is a collection of folders that we start off of. When the big container for Unity, to start off a Unity project, is the scene container. Think about the scene container as each of your screens, right? So each of the scenes is its own individual world, okay? So imagine this scene here is anything that the camera is going to see for the first time, right? It contains a world that's literally limitless in terms of how big it can be, based on your memory and your CPU, of course, the ability for you to handle things in this scene. The more things you put in the scene, the more objects you put in the scene, or that you show in the scene, the slower things get, generally. Okay, so you keep your scenes within reasonable size. But notice that there's no place to put my scene right now, and on the right, inside my assets folder, so I've got my assets folder highlighted, which is by default, and on the right, I can specify other folders. And I'm going to right-click here inside this area, and I'm going to create a new folder called _scenes. Now, if you've seen me do this before, it's just refresher, right? _scenes. And notice my little slider bar on the bottom can make it big or small, the size of the folder. I like to make mine a list because it's easier for me to see. And that'll be on the left, all the way to the left. If you go all the way to the right, it becomes a big icon. I'm not really good with icons. I never use icons in my real operating system, so I go right to my list view. And that's up to you what you want to do. This is how I do it. All right. I'm also going to create a couple of other things. So there are a couple of other folders. One, I want to have some kind of scripts folder, and again, I'm going to use the underscore for scripts. I want to put my scenes and my scripts at the top because those are the most common folders I'm going to be in and out of all the time, right? or away from the other stuff. The other ones I want to put in is any kind of textures, materials, whatever you want to have in here. I want to put other folders in here. And the one I gave you was textures. So I'm going to create that one. So create a new folder. We're going to call it textures. That's interesting. The word textures is kind of counterintuitive if you don't know anything about games, right? It almost sounds like there's something texture, like you can touch something, right? Texture means in our language, normally in English and in other languages, means something you can touch or maybe feel, right? That's what texture means. It's having a texture might have a roughness or some kind of feel to it with our hands. Or sometimes when you eat something, I'm just thinking off the top of my head, beef tripe. You ever have beef? Anyone have beef tripe, right? Beef stomach. That's what it is, right? It's kind of weird. It's got a weird texture in your mouth. So you can actually feel with your tongue in your mouth too, right? Same thing with chicken. Chicken feels different in your mouth than beef, right? It's a different kind of texture. The feel of it is different. So we use texture for that thing as well. Texture for what we touch, texture for what we have in our mouth, texture against, maybe our cheeks, when we how we feel outside, or how our cheeks feel, or our skin, those kind of things. But typically we don't look at textures in terms of visual textures. When we say texture, I want you to think about it as an image, right? It's an image, a flat bitmap, all right? And we're going to use this flat bitmap to create an illusion of a texture on an object. It's going to look like the object has some kind of shape, right? That's what textures are. On the right, up here on the top, the hierarchy. This tells us all the objects. And by the way, this little arrow, notice it says untitled. If you click on the little arrow, it shows you any objects that are in the scene, right? Right now, the only object that's in our scene is the main camera, right? The camera is the viewport. I want you to think about it as this is our eyes, our eye view into the entire world that is the game or the application you're creating, all right? That's the camera. The camera is set up with certain defaults, but I want you to think about this. All game objects in Unity, all of them, have this component up here at the top. Actually, all game objects in general, right? Every game object we ever use in Unity is a series of components. You have the game object class itself, and inside that game object class, the default component that everyone has is the transform component. This transform component, all game objects have. What is the transform component? Position, rotation, and scale in 3 dimensions. Okay, we have 3 dimensions here, but we're only working in 2 dimensions here. Why? Because we're ignoring the 3rd dimension to speak, right? If you think about this. Again, if I was to click on 2D, and if I was to pan around the scene, you can see that I'm just using my right mouse button here, and I'm using the scroll wheel to scroll out. You can see that my scene is actually a 3-dimensional scene that's flat. And it's because of the way I'm looking at it with my camera. My projection from my camera is looking at it as if it's a 2-dimensional object. It's very square, right? And if I change this from orthographic to perspective, you can see automatically how my camera now sees it as a 3-dimensional image. That's totally different. Now, we don't want to go there. We're not going to make a 3-dimensional slot machine. Although if you do for this assignment, and I'd be very surprised if you do, if you go there, I'll give you bonus marks. Make a 3D slot machine with a real texture and everything else. Good luck, right? That'd take me all semester to do, right? But if you have that kind of skill, all the power to you. So I want to go back to from perspective to orthographic. So what is perspective and what is orthographic? And we have to talk about that a little bit when it comes to 2D, anything 2D at all, right? That's all right. Let's start our camera. And I'm going to go back to my 2D view by clicking 2D, this little button on the top here. So now it looks just like what it would look before, like a little graphic. It looks like 2D, right? And that's it. Okay? Don't worry about what it's doing. But I want to use another tool to help us understand, to help us visualize what I'm talking about here. All right? I'm going to put up a tool called Blender. Blender is an open source tool you can download and install on your machine, right? I'm using it just for visualization, so you don't have to do anything here. Just watch. All right? Right now, you can see in Blender, right, that we have a cube, right? And it looks like it's 3D. Is it really 3D? Our cube, is it really 3D, real life? Like right now. Is it really 3D? No, our cube is actually, we're looking at a 2D screen, right? How can it be 3D? I don't see a cube back here, right? It's not really 3D. We think it's 3D because of the way it looks, right? If I pan around the scene, right? So if I pan around the scene or whatever, or or tumble around the scene is actually the right way to look at it. Around the center point, which is the Z direction here, the arrow, right? You can see that the cube appears to be moving as well, but that's not really happening. What's really happening is my perspective is changing, okay? So with games and all interfaces, whatever we see on the screen is 2D. We're translating an object that's stored as a three-dimensional object in 3D to an object we can perceive on the screen that is displayed in 2D, always. So this screen itself, this physical machine that I'm looking at right here, the projection that you see on the projector, you're actually seeing in 2D, right? It's flat. There's no substance to it whatsoever. You can't touch it, right? But why is it appearing in 3D? Because in 3D, we have a perspective. In real life, our eye sees objects farther away, smaller than the objects that are closer up. If I, bring an object that's really, small closer up, it can look rather large if it comes close to my eye. But the farther the object goes away, it becomes smaller and smaller until we can't see it anymore. And a good example, ever play the game where you go to, anyone go to New York or some place where there's big towers, and you just go like this with your hands, you take your thumb and you take your forefinger, you look at it and you go, look, I got the tower in my hand, right? Because it's almost like you've seen that little tower, but it's physically sitting here, right? Try to do that with somebody's head. Yeah, I got squish your little head, right? It's like that idea that you can see someone, it looks like you can actually see somebody's head inside there. I'm looking at you, see someone's head, and then, but I'm not really seeing your head. My fingers are, closer to me than your head. So your head seems farther away, and my fingers are closer, so they seem closer up and bigger, but they're actually not. Your head is obviously bigger than my fingers. Our eye perceives things that way, right? We see things that are farther away that are smaller, and things that are closer are bigger, right? But the shape is proportional. Well, this is the perspective view. This is the idea of perspective view, where our perspective changes according to where we sit in the scene, right? And if I was to look at this in orthographic view, let me just shift it. So I'm going to go to my object, right? And if I go to view here in Blender, and if I go to perspective view, from perspective to orthographic, what do I see now? Well, you know what? The object, even though I'm looking at it in perspective view, look at the object. The sides are all equal in length now. It appears that the sides are all equal in length. Orthographic view switches from, it doesn't make it so that the things that are farther away look smaller. They actually all look the same size. And if I show you this, right, if I kind of duplicate the cube and put it over there, they're looking like the same size now, right? The exact same size cube. Even if I put this cube further back, right, this is way over here on the back end, and looking at it, and I'm going to take this cube over here, and I'm going to move it to the front, right? Here's the front. Do the cubes look different in size? No. They look the exact same size. The proportion is exactly the same. But this isn't realistic. This is orthographic view. This is us looking at it and saying, we don't want to do a depth test. We don't want to look and see how far the object is, right? Everything appears to be the same exact proportions, right? This isn't realistic looking, right? In fact, this is really looking at projecting something that's a 3D image into a kind of a 2D perspective, right? If I was to change this back, if I go back to perspective view, you can see the difference now. This is what really is happening, right? An object that's the same size, is closer, is bigger than the object that's farther away, right? So our camera, when we see, this is just basics, a camera that's using orthographic projection is doing exactly that. It's making everything flat. Everything appears to be the same size, even no matter how far away it is from you. It's almost like we're not doing that depth test that we normally do with our eyes. How do we perceive depth with our eyes? Well, part of it is the way our eyes are shaped, but the other part is that we have two of them, right? We have one eye that looks at the actual image, and the other eye allows us to line things up, and with some form of parallax allows us to get this sense of depth, this depth sense, right? That's why we have two eyes, right? Similarly here, we only have one eye. We have a camera, right? And the way the camera works is how wide the camera can see, right? So angle of view, field of view will be like over here like this. That's how wide the camera can see in this way and this way, right? And usually the field of view is proportional, right? So the angle that we can see to the right, to the vertical field of view in the camera looks this way, and the horizontal field of view looks this way, right? That's one thing. And then the other thing is this idea of this near plane, which we can't see, and the far plane. And to show you a good picture of this, if I was to show you, just to go on the web here and say, if I said camera field of view, right? Here's a good example of this, all right? So here's the actual camera, and then this is the image plane, the plane that we're seeing, and there's something called the near plane and the camera frustum. I want to see if there's a good picture for that. And there's also the far plane. This is a pretty good one. All right, so I want to kind of, maybe we can go into this one and it won't kill us. Yay. So I want to kind of just use this one just to show you, right? So what I want to, I'm just using this for the image, not for the actual thing. But the idea that there's a near plane, so this is your camera, and this is your near plane, and this is your far plane. And anything between the near plane and the far plane, you can see, right? Anything outside of that, for the camera, up here or in here, can't see. All right, these things, anything outside of that is clipped, right? It's just not seen. So that means that there's, even in real life when you're playing a video game, right? You see something that if it gets too close, you can't see it anymore, right? If it comes too close to the camera. And that means it's between the camera and the near plane. It's too close, right? This is the near distance. And then there's this idea of the far plane. Anything beyond the far plane, you can't see. It's inside the world, but you can't see it. The other thing that I want you to think about is this, right? Going back to Blender. See the scene? These are objects in the scene. They exist, yeah? But what if I was to take this object here, right, and put it way over here for a second, right? Does it still exist in my scene? Yes, it does. It exists, right? But it's being clipped. I can't see it. So it's not being drawn to the screen, right? So the computer keeps track of it, but doesn't actually render it to my view, right? It exists in my world though, right? So hence, if I build my world, my level, the way I want in a game, right? I can put many things that are outside of the camera's view, outside of the screen. Can't see it, right? But as I move my camera and as I move closer to it, it becomes closer and closer and I can see it as it comes closer, right? So even though it's outside of the camera's field of view, right? In this case, you can actually still see it, right? If I was to move here, like this, where you actually physically can't see it, right? Just the way I put it, it's way, way in the corner here. Let me just move it off the screen. Woo, there we go. Can't see it at all now, right? You can't see it, but it's actually physically still in the scene, right? So too do games work, right? Anything that I don't want to show on the screen, just move away from the camera. Okay, I want you to think of that. When we do games, we build games for, with whatever we're doing. A lot of the things we do, they're tricks, all right? Everything from the way we fire bullets to the way we traverse the world or whatever, it's all tricks, right? So a little bit about the camera frustum and the ability for us to see close objects and far objects. I just wanted to use Blender for that to illustrate that. So back to Unity. So when we look at our projection, it's orthographic, which means it's just a flat view. It's really a camera, right? The camera is actually looking at a very deep, many, many levels deep, right? We don't have to make it so deep if we don't want to. But what we're actually looking at is a camera that's seeing a big projection that's way in here. Anything that's in this view right here is something that the camera can see. All right. 1. 2. The idea of game objects, right? Game objects. So if I was to go to the Unity API documentation, right? So if I go to Unity, right? Game object. You actually search for that. It's got really great support. One thing I really love about Unity is they have fantastic documentation for everything that they have, right? Notice that the game object itself, I'm just make this a little bigger for you guys to see it. So my resolutions are really crazy today. It has a bunch of variables and constructors built in. Imagine a game object is just a C# class, okay? The game object itself has some variables that are built in, scene, layer, and so on. These things are built in. Also the transform, right? The transform is a pointer to the component. I want you to think about the game object as a container, right? It can contain a bunch of other components inside of it, right? So the game object is just a big container. But the main thing that all game objects have is the transform, because we need to know where they exist in three-dimensional space or two-dimensional space, right? They have position, the rotation, and the scale, right? Those are the three things that all game objects have, right, in Unity. Okay, so it's game object. They also have a bunch of other functions that you can tap into. So if you ever want to do some special effect, it's here in Unity. Okay. Scripting in Unity, well, the way we do it is we modify game components. We refer to them. Okay, that's what we do, right? So if I go back to Unity, and if I right-click underneath my main camera, and I right-click and I add a new empty component. Here's an empty game component, empty game object. Notice that all it has is the transform. That's all it has. Position, rotation, and scale. That's all it has, right? Now it exists in the three-dimensional world. And if I was to find this game component and I want to see it, if I press F for frame select, and I come closer, can you see the game object? It's really hard to see. Here's the window, but where is that game object? It's kind of hard to see, right? Take a look again. Do you see it? It's right here, right? So to see certain things, you can't really see it, but to really see them, there's a way of tagging them in three-dimensional space, right? So on the right with the game object, by the way, we can call this whatever we want, right? Right now it's called game object, but I want to tag it. You can actually pull down this little cube here and change its color so you can see it in three-dimensional space, right? Now when I zoom in, or my game component itself, you can see that this is an empty game component that just has a transform. Okay. Why am I showing you this? Because without ideas of game components, drag and dropping things like images and all that kind of stuff into the scene, you don't understand. Let's try this out. I'm going to drag and drop some of those components that I had before. I'm going to delete this component. I'm going to drag and drop some of those components into my Unity file, the ones I already gave you, right? So I'm going to close down Blender for a second because we don't need it. We can go back to it later on. But inside my start files, right? Inside my start files, in what I gave you, right? In your files up on Blackboard, I gave you a couple of textures, right? So if you look at the actual files inside my assets, I have a textures folder. These are all the textures, right? I also copy them over here on my desktop, right? So let's suppose I want the Unity graphic to be included in my textures, right? The great thing about Unity is you can just drag and drop. So I'm going to bring this over here like this, grab my graphics, right? So it doesn't matter which one I take. I'll just take this one. And I want to find the slot machine graphic. Here's the slot machine graphic. I want to drag and drop this slot machine graphic into my Unity project. Drag and drop, watch. Whoop. And I pull it into my textures folder and let go. What Unity will do is we'll take it and convert this graphic into something that I can use automatically. So if I double click on my textures folder, I have my slot machine, right? There it is. It's not a game object right now. It's just a texture. And a texture has a bunch of different properties, right? The texture type and what kind of mode it has and so on. None of this you have to worry about for our particular example. These are kind of out of scope because we're not making games. But one thing I can tell you is if I drag this texture now into the scene, Unity will automatically convert it to a game object, right? So if I grab this texture, drag it in, and then bam. Now, not only is it a texture that says slot machine, but it also has two components now. We have a transform and something called the sprite renderer. The sprite renderer is actually the thing that's going to draw the image that's on my screen, that's my texture, onto this particular object. So if I zoom out, if I press frame select, right, it's as simple as that. Like truly that simple. I just dragged and dropped it in, and there we go. We have our background, right? Any other game object I want to include, and if I was to grab and drag and drop those things, let's say, for example, I want to add that button again. So here's my spin button, right? So I take my spin button here, and I kind of put it in here, drag and drop. and I drag and drop this button on here, I could do that. All right, here's my spin button. If I really want to, I could do it this way too. Right, here it is. I wouldn't do this in Unity because I told you buttons should be on the canvas, right? But I could. I could drag any button, any object I want into the scene, and it'll be its own image. In fact, I can make the spin button a child of the slot machine by drag and dropping it inside the slot machine object, right? It has its own coordinate system, right, which is relative to the parent. So the parent is the slot machine, and the spin button is a child of the parent, right? So it's actually it's molded or we say parented to the slot machine. Okay, we wouldn't do it this way, but we could do that. And I can go ahead and drag and drop some other ones too. Like let's say, for example, I want to drag and drop that blank. Not only can I drag and drop it, but I can test it right on the screen. So here's my blank. You can see there's my blank. I'm going to zoom in here so you can see the slot machine a little better. Notice this is just a blank image that I want to kind of start setting up my slot machine with. I want to start testing out what it's going to look like, right, ahead of time. And it's a kind of a visual medium, right? So I kind of drag and drop this stuff in here. It converts it, and then I can automatically use it, right? So I can see what it looks like. Okay. All of these are game objects. Anything I drag and drop onto my hierarchy becomes part of my scene. Okay. Now, in order for me to remember that I've dragged and dropped this stuff, I have to save my scene, right? By the way, even the spin button doesn't have to be a child of the slot machine. But one thing to note is this. They're all at the same order. So you notice that the order in layer is 0, right? And the order in layer basically says, hey, how are these images arranged on top of each other, right? Because remember, we're just seeing it in a camera. The camera's seeing actually 3D, but I'm seeing one on top of the other one, right? Well, order in layer helps us with that. So example, let's say I want to take this spin button for some reason and put it on top of the 7, right? Notice the 7 appears in a higher order than the spin button. Spin button seems to be behind, and the actual slot machine's behind that. How do I change this order? Well, order in layer helps us with that. So if I want to put the spin button on the top, I can change the order to, like, I don't know, 100, right? You can see that it becomes higher up. I can see it doesn't get obscured by the background. If you were going to do that, see? If I wanted to change the 7 to be higher, then I could make this, I don't know, 200. I can take this. Now the spin button will go behind. Click on the spin button, it will go behind the 7 again, right? But typically we don't want to make such big jumps. Typically what I want is everything on the same level should have the same order. So all images that kind of come up on the reels, they should have an order and layer of probably about 1. That's my recommendation. And any kind of controls like spin buttons and other things like that, any kind of labels that you want in here, they're going to have an order and layer of like 10. Right? Oops. 10. Here. Notice what I'm doing. Just like we do in Visual Studio, anything that we click on the left-hand side, on the right-hand side in the inspector, I want you to think about this as the properties for the object, the control, just like we did in Visual Studio. That's the analog, right? So when we have our form in Visual Studio on the left, right? On the right, we have our properties. And this is why I set up this way. So it's very similar to what you already know, right? So it doesn't confuse you. I don't want the interface to be a block for you, okay? Just the organization is slightly different. We don't see a solution explorer. There's no solution explorer. The solution is right here in our project with our assets folder and any other subfolders. Everything is an asset, in fact, right? Because everything is, at the end of the day, a game object. Anything you drag and drop on the screen is a game object, and therefore it's an asset. It's just a different type of asset. That's the philosophy that Unity uses. Okay. So that's neat. These are kind of cool. How does scripting work in Unity? And I want to go very, very high level here, right? Well, the way that scripting works is a couple ways, right? One, whenever I want to have a script that's attached to an object, I'm just going to get rid of these, by the way. Oops. So I want to get rid of all these ones. So I'm going to kind of highlight the slot machine. Actually, I'll keep the slot machine there, but I'll get rid of these ones. So I'm going to delete them, right? Let's suppose that you're normally used to double clicking. Double click and then I get an event. That doesn't happen in Unity. In Unity, you have to kind of attach a script for Unity to do something, right? You have to attach a script. How do we attach a script? Well, notice over here on the right, if I want to attach a script, right, to the slot machine object, and I'm sorry that it can't be a little bit larger. I mean, I guess I could have made it differently in my editor. But if I want to attach a script to my slot machine for whatever reason, so when the slot machine loads, something happens, right? I can click this add component object right here. Add component allows me to do things like attach physics to something or add a script. If I go to script, and if I go to, I want to add a new script, I can do that right in here, right? If I have a script that already exists, or if I scroll down, new script, I can choose the language. C# is the default, but you can also choose JavaScript. Highly don't recommend JavaScript as the language you want to use, right? Because it's a little bit slow, right? Still though, I want to point two things out. Whenever we program with Unity, even though we're using C#, and it looks just like C#, it's really scripting language. That's what it is. Because we're going to take C#, we're going to use the API, and we're going to translate it into something that Unity understands, right? But it's really, really light scripting. That's what we're doing with C# in Unity, okay? What can you do with Unity? All right. Well, let's suppose that I want to make it so that my scale. I want to rescale my object. So when it appears in the screen, I want it to be half the size. I don't know. How do I do that? Well, first I want to choose there's a couple ways to make a script. I can make it in here by adding component, or I can go in my scripts folder and right click and create a new script. I want to make a new C# script. This is my preferred method because it puts it right in the right spot. Okay? Are you good, or is that a hand? Yeah. Let's call this I'm going to call this the slot machine script. So I'm going to call it slot machine. Press enter. There we go. Slot machine script made, right? Now it's not attached to anything. I just made a script and it's just inside my folders. In order for me to make it work or instantiate the object that is the script, as an example, I have to attach it to an object in the scene. Okay? So my slot machine is the object. I can now drag and drop my slot machine script from my scripts folder until I get a plus sign on the object right here. If I let go, now this slot machine script is connected to my slot machine object, my game object. So it's another component actually. Notice that there's 3 components now, right? Actually 4. There's the transform, there's the sprite renderer that shows everything on the screen, there's my script, as well as some kind of default material, which we'll talk about later. If I double click on my script, it's going to bring up my default editor. In my case, it's mono-develop, right? Here's to note something about scripts in Unity. All scripts in Unity give you these basic methods, the start method and the update method. What are those two things? Unity triggers, or the game loop in Unity happens every 60 frames every second by default, right? That means every 16 milliseconds, that update method is triggered, okay? So if you want something to happen, like an animation or something like that, you're going to put it inside this update method, okay? There are many kinds of update methods. Actually, there's a few. There's update, fixed update, right? Late update, bunch of updates, right? And they work because of the way Unity triggers its event system, okay? We usually use update for anything that's not physics-oriented, right? Update. If I'm going to do any physics in my game, gravity, bullet effects, all that kind of stuff, I'm going to use fixed update. And the way I like to remember that is physics sounds with like an F sound, right? And so does fixed update. Physics, fixed update, right? Update for everything else. And late update, we do late update for other special effects. But typically, update is something that occurs once per frame, like it says here. Every frame, each frame is 16 milliseconds. That means I can run 60 frames in 1 second. Every second, my screen will refresh or be redrawn 60 times. That's what's happening, right? So this is where any kind of special effects can happen. My start method, this is interesting. I don't have a constructor in my script here, but I have a start method. My start method in Unity is actually being triggered by the constructor, right? So my object is being created, right? In this particular case, the object is the slot machine object. That's what it's going to be. The object is being created. And then notice that it inherits from mono behavior. The colon in C# means inherits from or extends the mono behavior class. Right? Mono behavior is the default class that all other classes inherit from pretty much in Unity, right? It's actually the class that the game object inherits from. All right, so slot machine, here we go. Slot machine is inheriting from mono behavior. This is the slot machine class. It has two methods, the start method and the update method. We initialize stuff in the start method, and we update things in the update method. Okay, so I want to have access, I want to gain access to my transform component, right, in Unity. Remember, all game objects have a transform component. And I want to, as soon as the application starts, I want to change the transform component, right? I want to change the transform component so that it shrinks everything to half the size. How do I do that? Well, let's take a look. I need to make a reference to the transform, but I can do that by saying something like as simple as transform. Transform is actually the transform of this object. That's what this object is. I can type in transform, you see it came up, right? And if I click dot, right, transform dot position, right, is the position. Transform dot rotation is the rotation. Transform dot scale, right, and it's actually local scale is what you want, is the local scale of my object, right? And if I want to set it to something, right, and if I want to know what local scale is, right, because local scale, if I'm going to go back there just to show you something, right, to get a hint of what to do, right? So I'll go local scale, right? Local scale, look what it says. It says the type that it needs is a vector 3. Oh, man, what the heck is a vector 3? Okay, now math. What's a vector? Anyone remember? Simple math. Vector, what's a vector? Direct, it's got what? A direction? Magnitude and direction, right? But I want you to think about a vector here in Unity, not just magnitude. So it's a point, right? It's a point in space that has magnitude and direction, right? So I'm going to get x, y, and z in a vector 3, right? Vector 3, that means 3-component vector, x, y, and z. Vector 2, 2-component vector, x and y, right? You can use these vector objects just like to carry data. Local scale requires a vector 3 object, right? Must have a vector 3 object. That means I must pass it a new vector 3 object, right? I can't just assign local scale.x, local scale.y, local scale.z some value. It's got to have a vector 3 object. Cool. All right. How do I do that? Well, I'm going to do something like this. Local scale, right? So I'm going to press dot local scale, right, is equal to a new vector 3 object, right? So vector 3, there we are. And I'm going to open it up, and it says, hey, public vector 3, there are 3 overloads, right? And if I was to go down, you can see that the first overload is an x and y, right? And then the third overload is a x, y, and z, but they're all floats, okay? Float x, float y, float z. I'm going to give it 3 components anyway. I'm going to leave the z component alone, 0, right, or whatever it's going to be. I'm not going to change that one because it doesn't matter. In a two-dimensional object, does it have a z? Is there any thickness to it? No, right? The z is 0 actually, right? It's flat, right? So I'm going to give it the components. I want to make it half the size. Remember, floats, the way it works is it goes from 0 to 1, 0 being no scale and 1 being 100%. It's normalized, right? It's on a normalized scale. It's from 0 to 1. So if I give it a vector 5, right, it means it's going to be 5 times as large. Right? That's what it's going to be, right? But I want to make it half the size. I'm going to go 0.5 f, remember, for float, and 0.5 f for float, and 0.0 f for float for the z. Does this make sense to you? So my scale on both the x and the y axis are going to be half the size, right? 0.5, right? And then my 0.0, my z is not going to change. It's going to be 0.0, right? Now be careful here. That we want to try and think about how this works, right? We're going to do a little example and we'll stop. Now you have to understand, where's y and z, where's x, what does all that mean, right? So I'm going to save this. Let's run this thing and see what happens. So whoop, run, right? And what happened? It ran, but then it stopped, right? Run. Oh, there it is. How do I tell that it's half the size? It showed me this thing here. Well, the great thing about Unity is even in real-time mode, run mode, I can modify my options. Watch. If I go to my slot machine right here, right? You can see that I have access to this. Look at the scale, 0.5, 0.5. If I change these numbers in real time, I can change this to 1, right? And I can change this to 1. That's what it really should look like, right? But what it's doing is, in real time, it's setting it to half the size here and half the size here. That's what it's doing, right? So in order for me to modify, what have we learned? In order for me to modify a game object, I need to hook into one or more of its components that I'm controlling. All right. Not a very underwhelming example, right? It's not really exciting for this kind of example. Again, if I run this thing, it'll go to 0.5 and 0.5 on the y, right? See? But let's go back to my little script, right? This is not really exciting, right? How about, let's try something else. I want to make my whole slot machine rotate 5 degrees every frame. Okay? I want to rotate 5 degrees every frame. How could I do that, right? Well, every frame, that sounds like I got to do something in here in my update, because my update updates every frame, right? And I want to change the rotation. I want to kind of add to the rotation, right? Now, I cannot access something directly. I cannot access my objects. Just like I didn't say local scale.x and local scale.y. I didn't assign them anything. I just selected a new vector. I can do the same thing, but I want to do this every frame, right? Okay, how do I do that? So I'm going to say transform.rotation is equal to, here's my new vector, right? But if I do this, if I do vector 3, oh, and if I put in some value, so first of all, how would it rotate? X is on the bottom, my horizontal, and Y is on my vertical. So it's got to rotate across Z, right? That's what's rotating. So X and Y stay the same. Otherwise, you're going to see some really weird thing happening where it flips around, right? We'll show you this in a second. So this is 0.0, always. You're not going to rotate here. But this, I want to rotate across my Z, right? I want to rotate 0. And this is something I want to show you. 0. Or we'll make it 5. 5. It's pretty big, right? Let's see what this does. This is 0.5. What is 0.5? Is it 5 pixels? Is it 5 degrees? What is this thing, right? And by the way, is this even correct? This whole thing, is this correct? A vector? Can I do that? Well, let's wipe it out for a second. I'm going to copy it, so cut it, and I'm going to go back here and look at what the rotation demands. So if I click on rotation, it says it's a public quaternion. What the heck is that? Anyone know what a quaternion is? Comes back to three-dimensional rotations. All right, how about an Euler? Right? Anybody know, understand those things? No? Oh, you guys are, linear algebra 101. Come on. All right. Well, a vector here wouldn't work, would it? Right? It's listening for a quaternion. That's what it needs. I need to assign it a quaternion, right? Okay. So can I do a new quaternion? Can I do like rotation is equal to a new quaternion? I could. What does a quaternion do, though? It has some values. It takes X, Y, Z, and W. Oh, my God. What is W? Right? Is there a W? Well, I want to think about quaternions as imaginary numbers, right? Because think about what we really have in three-dimensional space. There's this idea of a gimbal lock. If I rotate things, then I'll stop over here, okay, after this. But if I look at gimbal lock, right? talk about what this is in three-dimensional space. So here's this airplane, right? And you can see that, think about the red axis as the x-axis, the green axis as the y-axis, and the blue axis as the z-axis. Well, you're going to get into a situation where when you rotate across one axis and the other axis, you get something where all the axes come to the same point like this, right? Now you might say, okay, who cares? Keep rotating. But the computer trying to calculate with math what the next angle is gets confused, right? Doesn't know what it is when you start doing this with Euler rotations, like rotate this many degrees and across the x and the y and the z, right? And to fix this problem, we use something called quaternions, right? It's still a rotation, but we use an imaginary component called the W component. The W component is actually an imaginary number that we use when we rotate objects in three-dimensional space to avoid gimbal lock. That's what it's for, okay? Now, without going into too much of the math, that's why Unity requires a quaternion. You don't have to do it this way, by the way. Okay, I'm just saying, right? So it can take three objects. A quaternion takes, again, the options are x, y, z, and w, right? So again, I'm not going to rotate across the z. It's a float, 0.0f, or the x. I'm not going to rotate across the y, right? But definitely I want to rotate across the z, and let's rotate really quickly around 5. And we're going to leave our float, our W component, which is the imaginary component, at 1, which is basically saying don't do anything with the imaginary component, right? Just leave it there. Don't modify anything. We're not doing a translation. We're just doing rotation. All right. So save this file. I'm going to go back here, and let's see what happens now. Right? Does it actually do what I expect it to do? Well, it kind of did it, but it did it one time, and it went weird. Like, that's not 5. What 5 what? Right? It did rotate it, though, right? But somehow this is happening every frame, but I don't see anything. How do I modify this so that every frame it changes, right? Well, for this, there's a couple ways you can do this before we end for the day. I'm almost there from a time perspective. I want to have this update every frame. I want to almost add this in, right? It's almost like I need to know some kind of object in the back end. And what I can do is I can declare a float, right, of the object that I want to add in every frame, right? I want to be able to read the current rotation, right? The coordinate of the current rotation. So for example, rotation has X, Y, Z, and W component, right? Has that. So I can read. So I can say something like, you know, current, I want to set my current rotation as an object, right? So as a float, as an example, right? So my float, so we'll say current rotation is equal to the transform rotation. All we care about is the z, you know, dot z. So that's my float. Notice that float is only one of the components in this multiple component scenario, right? So that's my transformed as my current rotation. And what I want to do with this is I want to take my current rotation and I want to add something to it, right? Like, for example, I want to say my current rotation, I don't know, plus equals to, I don't know, 0.5 f, right? So I'm going to add 0.5 f to it every frame, right? Take my current rotation, I'm going to read it at the beginning of every frame. I'm going to read it. Tell me what my z location is, okay? My z rotation. Take it, add 0.5 to it every frame, okay? And then I'm going to take this current rotation and I'm going to dump it into here, right? So current rotation. Okay. Now every frame, that value will change, right? Whatever it was before, it's going to keep on adding it. We'll see how fast it is. It might be too crazy, right? Remember, these values are normalized. Does that make sense? Let's see what happens. I'm going to save this, go back to my screen here and press play. And if I did everything correctly, then we should have a spinning thing, right? Oh man, what happened? How come it's not spinning, right? Doesn't keep going. It did spin for a bit, but then it stopped. Any ideas? Now, you'd be forgiven to think that you can do something like this. Transform.rotation is, instead of this new rotation, is equal to, if you try to do something like this, rotation dot on my Z, if you try to do this and say is equal to current rotation, is equal to, if you try doing this, right? That's the one component, the float, right? So you should be able to do that. If you're thinking about this, right? So current rotation is going to keep on increasing. And I'm going to add this to the current rotation to the Z, and when it comes back around, I'm going to have that new location and add it on, right? So if I try to do this, right, it's going to say, man, cannot modify a value type return value of Unity engine. You can't modify it directly. You need to give it some kind of component. Does it really care if it's does it really care if it's a quaternion though? As long as I give it 3 components at least, right? It shouldn't matter, right? It wants a quaternion, but I'm not going to give it a quaternion. What if I give it a vector? Again, this comes down to just understanding, right? So if I said instead of my rotation, I want to give it a vector 3 object. No quaternion this time. Vector 3. I want to say 0. I'll give it 0, 0, 0. Let's say I don't even put the F's in there. 0, 0, and then my last one for this one will be my current rotation. Will it do this? Will it accept it? Will it give me an error? Right? Vector 3 object, 0, 0, 0. Let's see what happens. And play. Should give me the, oh man, what the heck, right? Just like it said before, right? If I look at my console, so for me, if I want to look at my console, I can go Window, Console, right? And I pull up my console over here so you can see what it says. It says, cannot implicitly convert type Unity Engine Vector 3 to Unity Engine Quaternion. Make sense? I can try. It's 3 components, right? But I need 4 when I do a rotation. My 4th component is that imaginary component, so we don't get gimbal lock, right? And that's why we need a quaternion. Okay. Oh, that's not what I wanted. So how do you get there? How do you understand where we're at? What is this value that we're getting? Are we getting a value? This should be firing. This should be triggering every round, right? Every frame it should be triggering, right? My current rotation. How do I do that? Well, what you can do is before you do this, you can do the same commenting and everything else you normally can do. So you can do something like this. I want to debug.log, right? And I want to send out to the debug.log my current rotation. So I can do something just like we normally do. Here's my current rotation, right? Plus my current rotation object. I'm going to send this out to the console, right? Now we should only see one value because we haven't added it into my transform yet. Okay, let's see what happens. So I'm going to run this thing. So go over here, run it, and we should see every round it's still 0.5, 0.5, 0.5. It's going to see. It's always going to be 0.5, right? Because we're not adding anything to it. So that's the first thing. It's just taking my original the Z transformation. And where is the Z? My rotation. If I look at on the hierarchy, if I look at my slot machine, you can see that my rotation right now is 0, right? Rotation 0, 0, 0, right? Okay, cool. Cool, I like that. So what else could I do, right? I want to kind of read what my transform is, right? So I want to add this to my transform. So let's do this thing. So I'm going to go back down to here, right? Do this transformation. Instead of a vector 3, we'll make it a quaternion like we did before, right? And we'll change this Z component. So the Z component is a 1, right? Notice that I have to put in F's when anything that's greater than a 0, right? Now let's see what's happening. If I run it again, and let's see what my thing is telling me over here. Well, this is interesting. Look, it kind of rotated it as much as it could. It went to 104, right? This is 104, and I can actually rotate it in real time here, right? Here's my 104, but it keeps on going to the point where it stops, right? It went to kind of 104, but then it kind of won't go past that point. How come? Huh? Hell no, there's no limit, right? Keeps going, and it stops, right? So why isn't it going any further? Why? It's trying to rotate, but after about 104, it's not moving anymore. It kind of stopped there, right? All right, let's make a bigger value. Let's, instead of 0.5, let's make it 5. Is that the problem? It's going to add in like, real numbers, right? So let's see what that does now. So here's 5. Well, I want to talk about 161 and then stop. Well, what happened? What happened with the console, right? So it's kind of got, pretty massive. It says 5.98633, right? And it kind of stopped at 5.985. Why did it do that? Right? Look, that's the current rotation is 5.9. The heck? What? It says 161 here, and it says 5.9 over here, and it's kind of stopped at 5.9. What am I getting back from my Z? Not getting back what I'm seeing here, right? So you're going to come across these issues when it comes to using Unity, right? And the reason why is come down to understanding. And I know we're running out of time. I'm going to stop now. But if I want to do something like simple, like rotate an object, rotate object in Unity, right? It's going to show you all kinds of patterns. That's why it's great to learn from. So if I go transform.rotate, there's actually a rotate method to do all the hard lifting for us, right? And you can see what it does. I can just say transform rotate to the right times delta time if I want to, plus the direction, and then where the delta time, where the range of stuff that I want to put in here. Vector right, by the way, is just an object that exists. It's a static that transforms everything to the right, three-dimensional space. So if that's true, oops, again, and then I'll stop after this, I swear, guys. I can just simply go like this. I want to rotate, instead of doing this all together, I can say, transform.rotate, which is right here, right? And I can choose this, whatever Euler angle I want, right? Notice X, Y, and Z. I can put that in there. So 0.0, and then dot current rotation in there. And I can get rid of this object where I'm trying to rotate my position, right? So transform.z, that's going to be interesting. So current rotation. But I could also just say my current rotation plus equals to, let's just not set it here. I can say my current rotation is plus equal to 5, right? So we can do that too. We can set up a class variable that says something like our float, which is our current rotation. We'll set that equal to, 0 at the beginning. And then we'll say, instead of redefining it here, right, we'll just say our current rotation plus equals to 5. And then we'll add in our current rotation to the rotation element. We'll do the rotate and see what it does now. And see if this actually does what I think it's going to do. Oop, I stopped it. That's why. There we go. It's going to keep on rotating forever and ever and ever and ever. And it's really, really fast, right? And that's just the frame rate of my screen that's happening. So if you wanted to cut this down even more, let's go to 0.5, really slow. And you can check out what it does as we go from there, right? Every frame. How come it's spinning out of control here? Because it's going to increase. I keep on making my current rotation increase to infinity, right? All right, take care, man. You're going to take off? Just saying, right? The other way around? Yeah. So then I can go the other way around by, like, let's say -5. I can go -5. And then do the other way around. Did I? All right, that's it for me for today, guys. I just wanted to show you that little bit of Unity I know it sounds complicated or whatever, but it's really not if you actually look into it. If you want to do this for next week, please have your interface ready for next week. For people who aren't going to do Unity, have your Visual Studio interface ready. And depending on how many people have Unity ready for me next week, that's what I'll decide whether I'm going to continue with one more week of Unity or else we'll stop. Okay, remember that there is no class on the 14th week, so there's no exam physically here in class. Your exam will be due by the midnight of that day. Okay? Thank you.